Hi, today I would like to introduce a new concept for an elastic deformable scale. You may see here an old steel yard where a certain weight can be measured moving this fixed load along this rigid arm. This is an ancient device which works on the principle of the lever, and a rigid body equilibrium is reached. Now I would like to introduce something completely different. You may see here a system idealized in the blackboard where this is a sliding sleeve in which this rod can freely slide. So if the rod is rigid, then hanging two weights P1 and P2, these two weights have a component along the axis of the sliding sleeve, and therefore equilibrium is impossible for this system. So for this system, rigid body equilibrium is simply impossible. But if we allow the rod to deform elastically, as it is sketched here, then things change, and particularly two configurational forces are generated. These are shown here, and in particular these are the squared of the bending moment, which is the load times the arm squared, divided 2 times the bending stiffness of the elastic rod. And due to these two configurational forces, equilibrium in the axial direction can be reached. And when it is reached, the deformed configuration is unique. So this system can work as an elastic deformable scale in which equilibrium is possible only because of the deformation of the system. Otherwise, it would be impossible. So we have prepared a prototype of this machine, which is this one. And you may see that this is the sliding sleeve and can get different inclinations. So if I take the elastic rod, in this case it's a blade, and I can insert it inside here, and now it is possible to hang loads here. Particularly, I can start with this on this side, and then I can hang a second load on the other side. Yeah, here we are. And of course I have to find the correct length for which equilibrium is possible, which is this one. So, knowing this load, knowing the arms and the deformation, we can determine that weight or vice versa. And of course, if we change one of these weights, we have to adjust the arms to get again the equilibrium. So if I add this little load here, it will be not in equilibrium anymore, so I have to change the configuration of the system. And now, for this length, I am again in equilibrium. So this device, this is a prototype, is simply a schematization, is a sort of proof of concept, but we think that something like this can be realized and used to measure weights. Particularly, this configuration is unstable. So if we, for instance, do this, then the system goes down that way. Otherwise, if you act in the other way, the system slips down this way. But there is a unique equilibrium configuration, which is in this case is this one. So we are proposing this device as a new concept of elastic deformable scale. Thank you for the attention.